We have seen polynomial space so far. In this video we consider sublinear space. So this is about sublinear space. And the classes we're looking at are L and NL. Okay, polynomial space, problems that are in p-space or that are even p-space hard, that are very difficult problems, they're really hard. Sublinear problems, on the other hand, they use a tiny amount of space. So first I'll start with the definition of L, and similar to p-space and np-space, we define L to be the class of languages that is decidable by a deterministic. So we also have the deterministic, non-deterministic cases by deterministic Turing machine in logarithmic space. And similarly, NL is the class of languages that is decidable by a non-deterministic TM in logarithmic space. And at this point you might wonder, how is this even possible, to have a Turing machine that uses logarithmic space? Logarithmic space means that the space the Turing machine uses is less than the input. Because if the input has size n, assume we have a Turing machine, and we have the input on the tape from x1 to xn, this input already takes, of course, n cells. So if the Turing machine is only allowed to visit log n cells, it would not be possible to read the input. So that doesn't really make sense, because without reading the input, how can you decide whether something is in the language or not? So what we do here is we extend our machine model. So we extend it in a way that we have a read-only input model, input tape. So we have an input tape, and this is read-only. Read-only input tape. And on this input tape, the Turing machine has a head and can move freely. However, it's read-only, it may not write on this tape. And we have a work tape. And on this work tape, we are allowed to use only O of log n cells. So the amount we may use in our memory that we can actually write, this is logarithmic, whereas we are still allowed to read the whole input on the read-only tape. So this is the new machine model. This one here is the new machine model, new model for NL and L. And now you might question whether this is actually useful to have this sublinear space. And actually it is a useful class, because assume you have a lot of data that you would like to analyze by a lot of parallel processes. And if the problem you're going to solve, you would like to solve, is in L. That means that it can be used by a lot of processes in parallel, and each process uses for its own memory only a small amount of memory, log n in this case, whereas it reads the whole data, but it does not write the whole big amount of data you would like to analyze. It simply reads it and uses only a small amount of memory for its own computation. So actually this class of languages that is L, that's the class that's easy to parallelize.